Okay, class, so we're looking at naming polynomials. So that's our objective. And if we look at the word polynomials, what we see, it has poly and nomials. So what does this mean? Well, if you look at the word poly, you've seen this before. Polygons. Polygon is many sides or many angles for a gon. So poly just means many. And nomials, what do you think nomials means? Well, we're in algebra, so we see things written out, and we have variables, we have constants. Well, nomials here refers to terms. So let's look at a couple of examples of this. Here is a polynomial, and remember what the word term signifies. This is a term in this polynomial. So 3x squared plus 4x plus 12. This is a term. This is also a term, and this is a term. So in this case, we have three terms for this polynomial. So this one has three terms. And what about this one? Well, if we look down here, this has 1, 2, 3, 4 terms. So this one has 4 terms. So that's what a polynomial is. And you can tell that we've worked with quadratics here, so something with a square. However, down here, this one has power of to the 5, to the 5th power. So we haven't worked with that yet. So when we're naming polynomials, because that's our objective, we're going to have two parts. So our first part of naming is we're going to name the degree, so the highest degree. And the second part of that is we're going to name the number of terms. So when we're naming a polynomial, we name it by the highest degree and the number of terms, and that's how we can signify what type of polynomial it is. Okay, so we are going to take two of our polynomials from the last page, and we are going to name them. That is the objective of today, is we're naming these polynomials. So I do that by having 2 degrees. So I have the highest degree. If I look in here, these degrees are in order. So it goes the degree of 2, 1, and this is a degree of 0. So what's something to the second degree? Well, we have a special name for that, and second degree is squared, but from last section we dealt with quadratics. So I'm going to call this one a quadratic. That's in the highest degree. And how many terms? Well, we have 1, 2, 3. So this is a quadratic trinomial. Now down here, if we look, we have 1, 2, 3, 4 terms, and the highest degree is now 5. So power of 5, we have special names for that. You can call it a quintic. However, we're going to simplify this, and we're going to say that something to the power of 5 is we can just say the 5th power. So this is a 5th power, and here we have 4 terms. So instead of saying like the special four terms, we're going to say 5th power 4-term polynomial. Now you might be saying, hey, Mr. Phillips, this is a lot more than 2 words. But we have the 2 parts. We have the 5th power, that's the highest degree, and the 4-term polynomial. So it's a 5th degree 4-term polynomial. And let's actually use the word degree here instead. So 5th degree. Okay, so take this chart down in your notes, write it in your notes, and on the left hand side we have the powers. So if it's power of 1, then we can simply say that it's a first degree polynomial. If it's a power of 2, we can say it's a quadratic, power of 3, cubic, fourth power is a quartic. And then when we get down to the fifth power, this is where I said that it's a quintic, but you can start calling it a fifth degree. And then we have 6th degree, 7th degree, and then it keeps on going. So for the powers, if it was 8 or 9, we would just say it's a 9th degree polynomial. Now for the terms, let's look at that. We have a first term is a monomial. Mon, the prefix meaning 1. Second term, binomial, trinomial, 4 terms, 5 terms, 6 terms, and so on. So take this chart down in your notes, and we will be using this terminology frequently, so you'll need to be able to understand when we say a cubic binomial or a quadratic trinomial, and you'll need to know what that means. Okay, let's look at adding and subtracting. So this is an operation, and if we add and subtract, what that means is we're just going to simplify, and you're going to do that by combining like terms. So all of the terms that you can combine, you will. So let's look at this. First thing in here is we see that this is a subtracting one. The subtractions are a little bit harder. And the first step that I would recommend is getting rid of that parenthesis by distributing the negative to everything. And by distributing a negative, that just changes the sign. So that's minus 2x to the 8th minus 7x to the 7th minus 3. Now we're going to go through and we're going to combine like terms. So we can see that this 3x here to the 7th and this negative 7x to the 7th is a like term. We have a 2x squared is by itself. It doesn't have any like terms. The 6x is by itself. The 2x to the 8th is by itself. And the negative 3 is by itself. So the only like terms we have are those two yellows right there. So when we write this, we'll write it in descending order. So let's write the power of 8 to the first. Then we're going to combine like terms. So negative 7x to the 7th plus 3x is negative 4x to the 7th. And my next highest term is the squared, so I have plus 2x squared. Then I have minus 6x minus 3. And this is my final answer. So I have this final answer. And if I look at this, let's name this. Well, we have to the 8th degree, so we'll call it 8th degree polynomial with 1, 2, 3, 4, 5 terms. So with 5 terms. And we have the name for it with the two basic parts. The 8th degree, and it has 5 terms. So 8th degree polynomial with 5 terms. Not a fancy name, but that's accurately describes what this is. Alright, let's do another problem. This time let's multiply. So in this case, we have two polynomials that we're multiplying. This is a polynomial. This is a 5th degree trinomial. And this is a 1st degree binomial. And we're going to multiply these two together and see what we get. So the first step is, let's take this term right here and multiply it by this term and this term. So 6x to the 5th. Well, one thing that we're going to come over here and show is before, we have to remember that if we have x to the 5th times x, that's equal to x to the 6th because we add the exponents. So like x to the 7th times x to the 8th is equal to x to the 15th. So we have to remember this property of when we multiply variables, we add the exponents. So 6x to the 5th times x gives me 6x to the 6th. 6x to the 5th times negative 2 gives me negative 12x to the 5th. Alright, let's take that away. And now let's go with the middle term. So the middle term, now we're going to multiply that by each term in this binomial. And 2x times x gives me plus 2x squared. 2x times negative 2 gives me negative 4x. And now we just have one more. This last term in our trinomial, we need to multiply to both of those. Let me move all this over. And that gives me 3 times x is plus 3x. 3 times negative 2 is negative 6. And now we look at this and we say, do we have any like terms? Well, this is the 6th degree, 5th degree, 2nd degree. Oh, but right here we have 2 like terms. So we have one final step, and that's just combining our like terms. So negative 4x plus 3x just leaves me a negative x minus 6. This is my final answer. And last step, let's just go through and name this. And since it's to the 6th power right here, we'll have 6th degree polynomial with 1, 2, 3, 4, 5 terms again. And that accurately names this polynomial. So a 6th degree polynomial with 5 terms. Okay, so you'll have lots of practice on this, and if you have any questions, make sure to ask.